our motto determine I naught with the help of Thevenin's theorem. So how can determine? First of all, that point and that point, this one is x and this one is a y. Consider, okay, that terminal no terminal x, here y. Okay, now next target is this one remove and we develop Thevenin's equivalent circuit corresponding to xy terminal. Okay, and after that we have connect RL load, it means 2 kilo ohm, then determine I naught. Okay, so how can do it? First of all make the circuit corresponding to VTH. VTH means V of OC. Clear? Our motto determine VTH means V of OC circuit. Open circuit voltage corresponding to these two terminals. Okay, so first of all make the circuit. If you make the circuit like plus minus, that is 2Vx, here 1 kilo ohm, 1 kilo ohm, here again 1 kilo ohm, and that is plus minus 2 volt, and here 1 kilo ohm plus minus Vx, and here 1 kilo ohm, and that is plus minus 4 volt. Clear or not? That is 4 volt and that is 1 kilo ohm, simply 1 kilo ohm. Clear? Now for motto we are focused on plus minus V of OC. Our motto determine V of OC. So how can determine? First of all we have considered loop current I1 here and here I2. If this one is I1, then whatever branch current, here also I1. Okay, I1 direction like this one, or I2 direction like this one. So here I1 minus I2. I2 is opposite to I1, loop current. So what about branch current? I1 minus I2. Here I2 plus minus, so plus minus I2. Apply KVL in this loop. Okay. What about Vx? Vx is also written as 1 into I1 minus I2. Basically you can say that I1 minus I2. Okay. Now plus to minus, minus 4 plus I1 plus 2 Vx plus Vx, this is equal to 0. So 4 this is equal to I1 plus 3 Vx. Vx means I1 3 minus 3 I2. So you can say that 4 this is equal to 4 I1 minus 3 I2. That is equation number 1. Okay, this is equation number 1. Now next target is apply KVL in this loop. Plus to minus plus I2 plus I2 plus 2 minus 1 into I1 minus I2. This will be equal to 0. Okay. So our target is, if you determine Vx, or you can say that if you determine I1 I2, then put this value in this loop. Okay. Now then we find V of OC. So how can determine? First of all determine I1 I2. So I2 plus I2, 2I2, and that is 3I2, minus I1 plus 3I2 plus 2, or you can say minus 2, equation number 2. Adding 1 and 2, adding 1 plus 2. Okay, adding equation number 1 and 2. Then we got 3I2 cancel, minus 3I2 plus 3I2 is cancel out, and 4I1, that is finally 3I1, and 4 minus 2, that is plus 2. Okay, so what about I1? I1 is written as 2 by 3. Okay, now if this value put here in equation number 1 or 2, So what about I2? I2 is -1 if this one is going on here, plus 2 by 3. So what about I2? I2 is written as, that is -6 plus 2 -4 by 3. So I2 is -4 by 9 milliampere. And what about I1? I1 is 2 by 3 milliampere. So what about Vx? Vx is 2 by 3 minus 4 by 9. Then we got, that is 9, and 3 to just 6, 6 plus 4, that is 10, 10 by 9 volt. Okay, now next target is our auto apply KVL in this loop. -2 plus minus V of OC plus 2 times Vx plus I2, this equal to 0. So V of OC is written as 2Vx plus I2. 2 into Vx, Vx is 10 by 9 and I2 is -4 by 9. Clear? So that is 20, here 20 minus 4 divided by 9, it is, that is 16 by 9. Okay, 1.78 volt. Clear or not? Okay, this is the final answer, that is V of OC, and this V of OC is called VTH. V of OC is called VTH, that is 1.78 volt. Okay, now so finally we got VTH. How can we determine VTH? First of all, this one is open circuit. After that, after open, here loop current I1, here I2, apply KVL in this loop, in this loop, then we got I1 and I2, and after that again apply KVL in this loop and we got VTH or V of OC circuit. Okay, first of all make it, after that we are focused on RTH. Make it. Now VTH is 1.78 volt. Okay, so next target is our motto, determine RTH. So how can determine? All independent source reduced to be 0. First of all independent source reduced to be 0 means voltage is short circuited and this voltage is also short circuited. Okay, so if you make the circuit, we are focused on RTH, means this one is also short and this one is also short. Clear? Now here we have taken 1 volt voltage source or 1 milliampere current source. Okay, clear or not? All independent source reduced to be, if you determine RTH means all independent source reduced to be 0, that is short circuit, that is short circuit. But here that is 2Vx means voltage dependent voltage source available. So how can determine this type of problem? How can handle this type of problem? If you consider here plus minus, or you can consider 1 volt or 1 ampere current source. Okay, if you consider 1 ampere current source, 1 milliampere current source, and that is plus minus V. Clear? If you focus on 1 milliampere means V is equal to 1 into IRTH, 1 into RTH. So RTH is V. So basically our motto, determine V. Clear? How can determine V? Clear or not? So next target is, clear? Now we have considered I1 Before consider I1, I2. If you see this circuit and this circuit are parallel, no, not parallel, because here X, here Y, that's why not parallel. So we are going to on loop analysis. Here I1, here I2, here I3. Clear? What about I3? I3 is here I3. Okay, clear or not? What about current in this direction? I1 minus I2. What about current going on in this direction? I3 plus I2. Clear or not? And what about current in this direction? That is I2. And what about current going on is this direction? That is I1. Clear? So here plus minus, here plus minus. What about I3? I3 is also written as 1 milliampere. Clear or not? That is 1 milliampere. Okay. Now follow this path. Plus to minus I1 plus I1 plus 2Vx plus Vx, this will be equal to 0. So 3Vx, this will be equal to minus I1. Vx is also written as I1 minus I2. So put this value 3 into I1 minus I2. This will be equal to minus I1. So 3I1 minus 3I2. This will be equal to minus I1. So 4I1. This will be equal to 3I2. Clear or not? Okay. So what about I1? I1 is 3I2 divided by 4. 3I2 divided by 4. Clear or not? Now next target is, means you can say that I1 is written as 3I2 divided by 4. Clear? Now apply KVL in this loop. Clear? Apply KVL in this loop, then we got I1 this equal to 3 times I2 by 4. Now apply KVL in this loop. Okay, plus to minus I3 is 1 milliampere. So 1 into I3 is 1. So 1 into I2. Okay, plus I2 minus 2 plus minus I1 minus I2. This will be equal to 0. Okay, clear or not? I2, 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 that is 3I2. So 1 plus 3I2 and minus I1. I1 is also put here, 3I2 divided by 4. This will be equal to 0. After solving, 4 plus 12I2 minus 3I2, this will be equal to 0. 12 minus 3, that is 9. So I2 put here, that is 4 by minus 4 by 9. Minus 4 by 9. Clear or not? Now next target, we got I2. I2 is minus 4 by 9. If this value put here, then we got I1 also. If you put here minus 4 by 9, that is minus 1 by 3 milliampere. Now apply KVL in this loop. Minus V plus 2Vx plus I3 1 plus I2. This will be equal to 0. So V is written as 2 into Vx. Vx means I1 minus I2. I1 minus I2. I1 is minus 1 by 3. I2 is minus 4 by 9. So that is 4 plus 4 by 9. Okay. Plus 1 and minus 4 by 9. So finally we got minus 4 by 9, sorry, after multiply, that is minus 2 by 3 plus 8 by 9 plus 1 minus 4 by 9. Okay, how can resolve this type of problem? If you take an LCM, that is 9, 3 2 is 6 plus 9 8 plus 9 minus 4. We got V, this will equal to 7 by 9. So what about RTH? RTH is written as 7 by 9 means 0.777 kilo ohm. Okay, clear or not? Now next target is plus minus VTH, here RTH, here RL. We got this one is 0.77 kilo ohm, or you can say that 777 ohm. Okay, and that is 1.78 volt. And what about RTH? RTH is 2 kilo ohm, or better to write 0.7. This one is written as 0.777 kilo ohm, and that is 2 kilo ohm. Our motto, determine I naught. So what about I naught? I naught is 1.78 divided by 2.777, 0.641 milliampere. This one is the final answer. Okay, clear or not? Simple. We got RTH. RTH is like this one, and after that put this value and we got I naught. Make it.